Hello viewers and welcome to a new STM32 World KiCAD video. It will be today. I am going today to talk about a feature I just discovered in KiCAD, and I think it's a fairly new feature called Jobsets. Now, an interesting part of KiCAD is that it's got a million features, and it's got a lot of features I probably never used, even though I used KiCAD quite a lot. But it's a very complicated piece of software, and well, I at least just discovered KiCAD as usual, and I've been told I have to mention this, otherwise people don't. Please do like and subscribe down below. It helps the channel, and it needs it. So please do. If you like these kinds of videos, please do like and subscribe. So a week or two ago, I made a relay board, which I got in the mail. Let me see. I actually also had here. I made a page about it, and I just wanted to test. This was essentially a prototype, and I just wanted to test it out. And I discovered a problem on one of the boards, but not the other. On the power supply, there's two power supplies on this board. There's a 5-volt power supply, and there is a, I should probably make this bigger so you can actually see it. There's a 5-volt power supply up here, and there's a 3.3-volt power supply here. And on one of the two boards I had assembled, the 3.3-volt power supply didn't work. Now, in the videos, I made a bunch of KiCAD videos, and in those videos, I went through the whole schematic design in KiCAD, how to design the PCBs, and finally how to order them at JLCPCB. And I've been using KiCAD and JLCPCB for years, and for me it has always been a manual process. I plotted the Gerbers, I zipped the Gerbers, I plotted I created the positioning file, I created the bill of material, all that. It was always for me a manual process. Now, it was a little bit annoying, but ordering is not something one do every day. So it was something I could live with. And I kind of, the process of going through the files, actually, I caught a lot of mistakes that way. But still, it's not the right way of doing it. So I just discovered that KiCAD have this new feature. I think it's a new feature called a Jobset. So let me show you what this is all about, and it is really a lifesaver. Now, I created a new project. I have not talked about this in any video because it's not really relevant, but if you go back and watch the video I did, it's actually here, about the 16-channel relay board with embedded STM32. Part of that is that there is two switch mode power supplies on that, and as I said, one of them failed. So rather than, this board is quite expensive because of all the relays, so rather than running a different series of these, I decided to create a power supply, just the power supply, and kind of it will be a cool gadget to have. So essentially, let me talk you through this. So this is essentially using the LMR 336440, which is 36 volt up to 36 volt in and 4 amps out. I think that is the 3640 is probably 40 amps, 4 amps out and 36 volt in. Now, the way these switch mode power supplies works is that you will have an output that goes through an inductor that charges up some capacitors over here, and then you will have, from this point, you will have a feedback. um, so that this can measure what the result actually is. And that feedback has to be around, or should I say, the switch will attempt to make sure that that feedback is 1 volt. So if this is below 1 volt, it will raise the voltage on the output. If it is above 1 volt, it will lower the output on the switch mode on the output side. Now, what I did on this board, just to have it, I made this variable. So rather than having this, it's a voltage divider. Rather than having a fixed voltage divider, I put a trimmer on it so I can actually adjust it. And in theory, this should be possible to regulate this from 2 to 12 volt by trimming this. So I'll have a little power supply board where you can put pretty much any voltage in, as long as it is higher than what you want out of it. And then you can trim it and set it to exactly. That would actually be useful in my case for some tests where I want to run a slight under voltage or over voltage to see how it performs. Now, on the relay board, I had a LED attached to the voltage, and because I knew the voltage was fixed, I could select a resistor to current limit the resistor. Now, that is obviously not possible on this board since it can regulate the output from 2 to 12 volt. So I have to come up with a way to not fry the LED. And this is a traditional constant current voltage. I can talk you through it briefly. It's basically 2 NPN transistors, and once there is a voltage here, this one will be at ground level, so this one will be off. When there is a voltage, it will pull up the base of this one. That means that one will start conducting, so there will be a current going through this, and that current essentially is limited by this one. So this and it will start pulling up the base of this transistor. Now, transistors, you know the voltage between the base and the emitter. So there is 0.7 volt here. So by 0.7 volt using Ohm's law divided by 220, you can calculate that the current that is going to go through this one. So it works. I actually did a simulation of this as well. Can't remember where. I might show that later. But it works. And that is about it. So let's look at the PCB. Now, this is a lot smaller than it looks here. It is slightly less than 20 millimeters, 19.05 millimeter that way. That's 2 centimeters. Very, very small. And it's about 2.5 centimeter this way. And if we look at the 3D, the biggest component is, of course, that trimmer. I wanted a trimmer that I think this one is 20 rounds or something like that. So it should be possible to trim this one fairly precise. I also, on this one, I used a cheaper, on the original relay board, I used a Coilcraft inductor, which was quite expensive. That one was, I think it was a couple of dollars per inductor. This one is 10 cents, Chinese no-name coil. We'll see if that works. And again, I'm just curious. This is cheap enough so I can make 10 of them and test all 10 and make sure that I didn't make a mistake in my design, or if I did make a mistake, I might be able to figure out what was actually wrong with it. So that was briefly about this project, and as usual, I would now have gone through the ordering process. So I would have started in the schematic, I would have plotted the SVG file, I would have created a bill of material, I would have gone over to the PCB editor here, I would have plotted the Gerber files. Down here, I would have created the positioning file. I would then have gone to a terminal. I would have zipped the Gerber files into a package and send it off. So I could send it off to JLCPCB. But let's look at what this video is really about. KiCAD have a new feature, or I think it's new at least, called Jobset. Now, Jobset is basically you can create a number of jobs and you can decide how many you want. You can have jobs like export DXF, export the net list, export PDF, export SVG, generate the bill of material, perform the electrical rule check, and then PCB you can export. So I have created a series of jobs here. First of all, over here in the settings of the job set, I have defined the output folder, and I call that rev underscore and then the revision. And this board is revision A. So everything I do here in this job set will end up in a folder called revision underscore A. If you look over here, I don't have that folder yet. This is the my working directory. That folder is not there yet. So then I'll export the SVG, an SVG copy of scalable vector graphic copy of the schematics. I use those primarily on the STM32 World Wiki, where I can upload the schematic of that. I also generate a PDF file. Some people prefer PDF. I generate the bill of material, and if we go into this, it actually it is the normal settings, exactly the same settings I would normally have used. I perform the electrical rule check. I export the Gerbers from this. I export drill data. I export the positioning data. I perform the DRC, and then down here I have an execute command. Where I call a script I call do-zip. Now, this shouldn't be necessary. It should be possible to call zip directly in here, but there is a bug that I can't figure out. I have created an issue on KiCAD. I don't know. It doesn't work if I do it the way I thought it should be done, but it works if I call my script instead. And here's a copy of the script. So I don't know exactly why that is. And the final job I execute is I fix the header of the positioning file. KiCAD use one header in the CSV file, and KiCAD JLCPCB expect another header. So anyway, that is it. So now I can generate all destinations, and this will run a while because it performs DRC, but it's already done. And you will see over here in my file browser that it has now created a folder called Rev A. Inside Rev A, you will have a Gerber subfolder, a subdirectory, and it will have the PDF generated. We can try to open the PDF, and it is the schematic. It will have the positioning files generated. It will have zipped the Gerbers into this file, and it will have the bill of material, and it will have the final positioning file, which is a result of this one being run through the fix header script. So for fun, let's try to go through the ordering process. Now again, let me be absolutely crystal clear about this. If I nuke this folder, now it's gone. I just have my normal working files. If I go in here and I generate all destination, it will do all necessary exports in this folder. So let's try to go to JLCPCB. If I could hit the right keys. JLCPCB is here. I'm already signed in. So let's go to order now. Let's add those. I go to that folder, the revision A folder, and I select the zip file, which should contain the drill files and the Gerbers, and we try to upload that. And with a little bit of luck, that just works. I order 5, and it usually stops here and then takes a little while. Sometimes it tends to. Here we go. So here is the two sides of my board. The dimensions of the board. Being so small, 1.2 millimeter is more than enough. I will specify the order number position, so we are still at $2 for 5 of these PCBs, plus shipping, estimate about $7. So let's try to, no, not save to cart, let's add the assembly. So we go in, we want to assemble on the top side. There is nothing more here, I want to say. So next. Now this, I'm not sure why JLCPCB show this page, but this is essentially the PCB. You can view it from both sides, but it mirrors the bottom side. I don't know why. But I usually check that these are white so that the drills, because I accidentally a couple of times uploaded without the drill file, that will be pretty obvious here because all the through hole pads will look like SMD pads. But this looks okay. There are plenty of drill holes, wires, etc. We can add the BOM file. The BOM file is the one I call PAUK CSV in this case. I can add the CPL file, which is the positioning file. There we go. Process BOM and CPL, and let's see what it comes up with. No complaints. Oh yeah, it complained that J1 and J2 and a jumper doesn't exist in the CPL file. That is because I didn't ask them to. I can solder in a header myself, and I'll do that. So I always look up here first. So I have exported 21 parts in the, and 21 parts was confirmed. So we go through this and it will take over here. One thing I always do at this point is I go through, because the JLCPCB, as mentioned earlier, have basic components and extended components. For extended components, you have to pay $3 per component, not per component per board, but $3 per component per order, for them to load it into the machines and stuff like that. That's fair enough. The basic ones, they're always there, so you don't have to pay this. So I always go through and look at the extended ones and see maybe there was a cheaper option, a basic option, but in this case there's not. This is just how it is. So my transistor is actually an extended. This is a double transistor, 2 transistors in one package. So it's okay. Cost so 10 of those cost 2 cents a pop. So they're cheap, but there's quite a lot of extended components on this board. But well, I'll live with that. Let's do next. And here we go. And here we always look at the orientation. So this one looks correct. There's 2 pins on one side, there's 1 on the other. This one looks like it's rotated correctly. The transistor down here looks like it is rotated correctly. And the diode looks like it is rotated correctly. So that is about it. Now, I'm not going to order it right now, but I probably will. So $40 for 5. It's quite expensive for one, but of course, if you scale this up, the expensive one, the one that makes it expensive is these $15 down here for the extended component fee. And if I made 100 of these boards, that will be significantly cheaper per board. Uh, Actually, we can try that. So let's go back to the PCB. Let's go back to a new order. Let's do two. So let's try to do panel by JLCPCB. I want to do a panel here. We can do 25. We could probably do that, I think. Top on both sides. Okay, let's try that. Oh, it was too big, so let's say probably 15 on one board. Why did okay. Sorry, forgot to upload the zip file. There we go. Panel by JLC PCB. Let's do 5 columns. Let's do 5 again. And let's do the top and bottom side rail. That looked acceptable. So there's 25 of them per board. And that means if you make 5, we actually get 125 of these by doing 5 of these panels. That's okay. Let's go down to the 1.2 millimeter. That's about it. Let's do the components. Now it will obviously be quite a lot more expensive, but single piece, please help me repeat the data. Yeah, they can do that. And POW and POS process. Continue. And now you see the prices. So there is the trimmers are actually almost 125 of those are actually almost $100. So that is by far the most expensive component, followed by the actual switch mode regulator. The rest is okay. It's quite a lot of LEDs, 629 LEDs. So that no, the capacitors. Sorry, the capacitors quite a lot. So yeah, let's try to see if it looks okay still. And it should be exactly the same as it was before. And I'm good with that. So let's click next and look at the bill. So if I want to make 125 of these, remember that 125 fully assembled pieces, that will cost me 300. So what are we talking? $2.50 for one of them. That is pretty damn cheap because the feeder's loading fee is still the same as it was before, and that is about it. So pretty much all I wanted to say again, I think this Jobset feature in KiCAD is really, really powerful and will save me a ton of time in the future when I'm doing these orders. So create a job set, fix the files once and for all, and then you can just repeat. And when I get to a point where I order this and then I find some mistakes and will run revision B, all you do in this case is I go in here in my schematic setup where I had the text variables and I will change the revision to B. And next time I click on the generate all, where was it? There. Generate all destinations or generate up here. It will generate a version B. Now, notice I'll keep these folders because I usually put that on GitHub. So I'll always have these production files for the old version, even when I generate a new version of this later on. That's about it. As I mentioned earlier, please do like and subscribe down below. And as usual, have a wonderful rest of the day.